Hi, my name is Tiffany Lara and this is my heat exchanger project. My heat exchanger is made up of 7 feet of 3/8-inch copper tubing coiled into narrow circles through the body of the coffee can. The inlet is here at this point and the outlet is here at this point after the swirl through the coffee can. The majority of the surface that heat transfer occurs is between the copper tubing and the water. Copper is one of the most conductive metals, so the hot water will cool significantly as it travels through the pipe. Since there are multiple coils traveling downwards, the hot water will cool to a lower outlet temperature. This heat exchanger is made out of 3/8-inch outer diameter copper tubing. My dad redid our kitchen and he had a length of copper tubing left over, which I was able to use. While I was satisfied with this, the biggest issue was that the water was not traveling through the copper tubing in less than 5 seconds due to the small outer diameter. I decided to alter my heat exchanger by applying a pressure component that would increase the water flow through the heat exchanger, as seen here. To create this pressure vessel and attach it to my heat exchanger, I used one 3/8-inch brass coupling, one faucet supply line, one 3/8-inch brass needle valve, one pressure gauge, one tire air valve stem, a paint can, and a bike pump. I had extra paint cans and a bike pump at home, and the rest of these items were purchased at the Home Depot. At the beginning of this project, I manually coiled the copper tubing into a small enough diameter so that it would fit into the coffee can. I cut these sponges here in order for it to line on the outside of my heat exchanger and secure it in place. Next, I used a Dremel to puncture 2 small slits at the very bottom of the can. Then I used a screwdriver to pry a hole large enough for the copper tubing to fit through. After that, I used the Dremel again to puncture 2 small slits at the top and bottom of the paint can, where I was able to fit the brass needle valve and the pressure gauge. I then used a screwdriver to create a small enough hole for the air valve stem. These items in the paint can were secured in place with a washer and a nut. After closing the gaps with JB Weld, as I can clearly see here, I was able to attach the coupling to the top of the copper tubing. Then I was able to screw the faucet supply line onto the end of the coupling and the end of the air needle valve. Finally, I attached the bike pump to the tire air valve stem and shut the lid on the paint can using a hammer. I measured the volume by taking a ruler and measuring the diameter of the largest coil, which is about 12 centimeters, and the height of the heat exchanger from the outlet to the top coil, which is about 15 centimeters. Since I need to find the volume of the smallest bounding rectangular prism that my heat exchanger will fit in, I used 12 centimeters as the length and the width. The smallest bounding rectangular prism calculates to about 0.002 cubic meters. Now I will begin my ice water bath. First, I will pour ice into about the halfway point of the coffee can. Now I will add the ice water to the coffee can. I made sure the top was frozen over so that the water would be as cold as possible. Here I'm measuring the mass of my ice water bath and heat exchanger. It's about 8 pounds, which converts to 0.45 kilograms. Now I will begin the heat exchanger experiment. First, I poured boiling water into the pressure vessel. Once the boiling water cooled to about 80 degrees, I immediately began to close the pressure vessel. I had to do this by using a hammer. I also stacked weights on the paint can to ensure that the lid would stay sealed. I initially opened the air valve to relieve any excess water that was still in the heat exchanger. My dad also started a timer so we can see exactly when I opened the air valve and started applying pressure. As you can see, that was at about 5.6 seconds. During this time, I was watching the measuring cup and told my dad to stop the timer when it was at about 8 ounces. Once the water hit 8 ounces, I moved the measuring cup away from the stream, as you can see here. It was slightly more than 8 ounces. Lastly, I showed the outlet temperature, which is about 110 degrees Fahrenheit. This converts to about 43 degrees Celsius or 316 degrees Kelvin. Here is the initial temperature at 80 degrees Celsius. We ended the timer at 14.15 seconds. Since my initial time was at 5.6 seconds, that means my total time was 8.55 seconds. As mentioned earlier, the mass of the heat exchanger and the ice water bath was about 0.045 kilograms, and the volume was about 0.002 meters cubed. Thanks for watching. I hope you enjoyed.